Hi, welcome. In this video, I will be presenting the CS144 MOOC programming assignment, the simple router. More precisely, I will show you how to set up the virtual machines that you will be using for the assignment and how to test your code within that virtual machine. The first thing you need to do is visit the assignment's webpage and download the virtual machine's image. We provide one 64-bit image and one 32-bit image. The 64-bit image should work fine, but if you are using Windows, it may be safer to use a 32-bit image instead. Each image is roughly 1 GB, so it's probably going to take some time. Although other virtualization solutions should work fine, we recommend using VirtualBox for the assignment. VirtualBox is available on most platforms, and this is the only one we have tested for the assignment and for which we will provide support. Each image, 64-bit and 32-bit, is provided in two different formats, .ova and .ovf. The OVA format is more recent, and that is the one you should be using. If you are using an old version of VirtualBox, or if you have problems with the OVA, then you may find the OVF useful. The OVA file is contained in a zip archive along with a virtual disk for the VM, so you will have to extract the zip to be able to import the OVF into VirtualBox. The OVA file, on the other hand, is self-contained, that is, the virtual disk is included in the file. Once the OVA file, or the OVF file, is downloaded, open VirtualBox and select Import Appliance. Select the OVA file, click on Next, and select Import. You do not need to change any of the default settings for now. Importing the appliance is going to take some time, so we're gonna have to wait. So once the VM is imported, there are a few settings we need to adjust, mainly to be able to connect to the VM through SSH. There are various ways of doing it. You can either do port forwarding or add an host-only adapter and assign it to the virtual machine. Port forwarding is a bit less constraining and may be a better solution. But because I use the host-only adapter on the web page, this is what I'm going to do here too. To create the adapter, go to File, Preferences in VirtualBox. Go to Network and click on the little plus sign on the right of the window. You can keep the default name for the adapter, vboxnet0, but you will need to change the settings by clicking on the screwdriver. You should not need to change anything in the adapter section, but if you don't have the same IPv4 address as me, you may want to change it now to avoid potential troubles later on. Go to the DHCP server section next and fill all the fields just like me. Enabling the DHCP server means that your VirtualBox will receive an IPv4 address automatically in the specified range every time you start it. Here, I choose for the IPv4 address range 192.168.56.10 to 20, which means that by default, your virtual machine should receive the IP address 192.168.56.10 the first time you boot it. In theory, we could even restrict that range to a single IPv4 address. When you have edited these settings, only one thing remains to do before you can power on the virtual machine and start the assignment. We need to assign this newly created adapter to our VM. In order to do that, just click on your VM in VirtualBox dashboard, then on Settings. Go to Network, click on Adapter 2, and make sure the adapter is enabled and attached to our host-only adapter, VBoxNet 0. If it's not the case, edit the settings manually to reflect my configuration. It's now time to boot the virtual machine by clicking on Start. It should not take the VM too much time to start, but wait until you see the login prompt. Here we go. You should not be using the VirtualBox terminal to connect to the VM. It's not very convenient. Instead, we are going to connect through SSH, which is the whole reason why we bothered to add a network adapter. So open a new terminal if you're using Linux like me or Mac, or open some SSH client like PuTTY if you're on Windows, and SSH into the VM. Now, the IP address should be 192.168.56.10 by default, but I'm still going to give you a way to check it, for which we need to use a VirtualBox terminal, but that will be the only time. So log in using the VirtualBox terminal, to credentials or Mininet and Mininet. Then type ifconfig, which will display a list of all the network interfaces for the machine. Here we can see we have three interfaces: the loopback interface, ETH0, which connects to the VM to the internet through a NAT, and ETH1, which is the one we are interested in. Look for the INET address and write it down. In my case, as expected, it is 192.168.56.10. Even if it's not exactly that, it should be in the range we gave to the DHCP server. Once we have the IP address, go back to your terminal or SSH client and connect to the VM using this IP. Once again, the login is Mininet and the password is Mininet. We're now logged in. The assignments directory is CS144 underscore lab3, which I agree is not a very good name. Go to that directory using CD, like I just did. To make sure you have the latest version of the starter code as well as the latest version of the reference solution binary, issue a git pull rebase request. And you can then look at the list of files. Your list may be slightly different if we updated the Git repo recently, but that's not a problem. The starter code is in the routers subdirectory, and that's where you will write all of your code. It is possible to write all of your router's logic in srrouter.h and srrouter.c. If you want to write more modular code, feel free to add all the .h and .c files you want. However, do not forget to also modify the make file, or your code will not compile, or you risk missing some files when you submit. Let's take a look at the make file now. So this is where you will want to add your header files, and this is where you will want to add your source files. Do not forget to do it. In this video, I will not do a review of the starter code because you will find detailed information on the project's webpage. Let's now see how you can run tests on your router. We provide a reference binary whose behavior you can compare to your own router's behavior. So it should be very useful for your debugging or in case you have a doubt as to what the correct behavior should be. Right now I'm going to show you how to run the reference solution. The process is the same when you need to run your own code. So the first thing to do is to start Mininet and POX. More information on what these two are doing can be found on the assignment webpage. To make things easier for you, I wrote a script that will start both of them in 2 separate screen sessions. If you're not very familiar with Screen, now may be a good time to learn a few things about it online, because I find it comes very handy for this assignment. So right now the script is called run_all.sh. Let's execute it now. Box will take a few seconds to start, so wait until the script is completely down and prints a quick reminder of the basic screen commands. Here we go. First things first, let's check if everything started correctly. First, Mininet. We connect to the Mininet screen with screen-rmn. Okay. Then we detach the screen with Ctrl-A, Ctrl-D, and we do the same thing for Box. Okay, everything seems to be in order. You do not have to do these checks every time, but looking at Mininet and Box can be useful if you're having trouble running the environment or if you need some help. Now it's time to run the reference router. Because we want to keep the terminal available, we are going to run the router in its own screen session. An alternate solution would have been to open a new SSH connection to the VM. So I create a new screen session with screen-S SR, where -s is used to give a name to the screen session. Once I am attached to the screen, I simply run the reference router with /sr solution. This will display the routing table here, as well as the interface's configuration here. We can now detach the screen with Ctrl-A, Ctrl-D. Everything is now running, and we should be able to ping one of the servers from the VM. First, let's find out server 1's IP by looking at the IP config files that we have. Here we go. Now let's ping it. So the first ping takes a bit more time because of the ARP request involved. Everything seems to be working fine. Let's look at the SR screen, where we have some minimal output. The 32-byte packets are ARP packets, and the 98-byte packets are ICMP packets. When you write your code, feel free to print more output to stdr if it helps you debug. However, it's a good idea to remove those print statements, or at least disable them with a preprocessor flag before submitting your code. So there are actually 2 ways of running tests: from the VM terminal, like I just did, or from the Mininet command line interface. The advantage of the Mininet command line interface is that you can also issue commands from the servers using exactly the same tools as you would use from the VM. So ping, traceroute, wget, and so on. Let's see how we can use the Mininet CLI. It's very easy. You just have to attach to the Mininet screen with screen-mn, and issue a regular command, but preceded by the name of the host you want executing it. For example, if you want to do a traceroute from server 1 to server 2, just type server 1 traceroute server 2. The dash and option I added tells traceroute not to do a reverse resolution in the IP addresses. Now back to the VM terminal. Let's now try to establish an HTTP connection to server 2 and download the index.html file. For that, I'm going to use wget, but you can also run curl if you prefer. I type wget, followed by server 2's IP. And it works. Let's do ls to look at the files. Index.html is indeed here. I remove the file now. So the process is exactly the same when you want to run your own code instead of the reference solution. Just cd into the router subdirectory, compile your code with make, and then run SR, just like you would run SR solution. When you are debugging your code, you may want to restore Mininet and POX from time to time in case something is not working. Let's see how we can restore the router as well as Mininet and POX. So to kill the router, simply attach to the SR screen session and hit Ctrl+C. If you want to kill the screen for some reason, use Ctrl+D. Let's go back to the VM terminal. To restart Mininet and POX, simply run the script run_all.sh again. It will kill the previous instances of Mininet and POX and start new ones. Okay, you can then start the router again, just like before, like this. In the final part of the video, we are going to see how we can log all the traffic going through your router and use it for debugging purposes. So when you start your router or the reference solution, you can use the -l option, followed by the name of the file where you want to log traffic. This file will be in the pcap format, which can be read by tcpdump and Wireshark. Let's look at an example. First, let me restore SR solution, this time using the -l option. I'm going to name my file traffic.pcap. Okay. I can now run a simple test, the one we did before. We ping server 1 from the VM terminal. So here I have sent 3 ICMP echo requests and received 3 ICMP echo replies in response. Of course, when I look at the pcap file, I should also see a bunch of ARP requests. We now kill the router with Ctrl+C and go back to the main terminal. So is the pcap file here? Yes, it's right there. Let's open it with tcpdump first to get the text output, and we'll see later how we can open it with Wireshark. So the command is kind of complicated. You just have to use the same one as me. tcpdump -n to prevent name resolution -www -r traffic.pcap. Okay, and we get the expected output. For example, we can see 6 ICMP echo requests. 1, 2, 3, 4, 5, and 6 ICMP echo requests. So we have 3 ICMP echo requests that were sent by the VM and received on ETH3, and 3 ICMP echo requests forwarded by the router out of ETH1. We can also include the Ethernet header information with the -e option, but as you can see, the output gets kind of messy and difficult to read, which is why we are going to see how we can open this file with Wireshark, which comes with a graphical interface and is much more visual. So first, of course, you need to have Wireshark installed on your laptop. Let's assume that it's the case. First, I need to import the pcap file from the VM onto my laptop, which I can do through SSH using the SCP utility like this. So I give SCP the path of the file on the VM and the local path where I want to store it. Here I store the pcap file and my documents. Okay, sorry about that. So once again, if you are using Windows, you will need some third-party software. I now open Wireshark. And import traffic.pcap. So as you can see, it's now much easier to see what's going on. It's also much easier to find out if one of your packets is malformatted, as Wireshark will signal it to you with vivid, aggressive colors, for example if you have a bad checksum. So I strongly encourage you to use Wireshark for your debugging. You should be able to find many good tutorials online to learn how to use it and get familiar with it. One last thing, for some of the requirements for your router, for example, to test for ICMP net unreachable or ICMP host unreachable, you will need to modify the default routing table. To do that, just go to the assignment directory and open our table, the our table file with an editor. So here is a default routing table. So now you can add entries or remove entries. Each entry is a line. So I think you can have more information in the assignment webpage about what these lines mean, and you will probably have more information in the lecture videos. But just to give a quick interview, so the first field for each line is the IP address you're trying to match. The second field is the next up's IP address. The third field is the network mask, and the fourth field is the outgoing interface. Again, maybe you don't know exactly what these fields mean right now, but you will after watching the videos and looking at the assignment webpage. Okay, that's the end of the video. To turn off your VM, just terminate all your SSH connections and select power off the machine, like this. Thanks for watching and good luck with the project.